Alright guys, today's video is on functions. This is section 1.4 in your books, and make sure you guys bring your book to class because we may use them. Alright, basically what a function does is it takes a set of numbers and maps it to another set of numbers. Okay, so in this example we have set A, which is the time of day in AM, and set B, which is the temperature in degrees Celsius. So for instance, this function maps 1 AM to 3 degrees Celsius. Basically at 1 AM it's 3 degrees Celsius. It tells us that at 2 AM it's 8 degrees Celsius, 3 AM it's 4 degrees Celsius, 4 AM 10 degrees Celsius, and at 5 AM it's 8 degrees Celsius. The input values is called the domain, and these are the values that get plugged into the function, and the values that get outputted are called the range values. Okay, and down here we just have points that represent the time and degrees that we just talked about. So 1 AM, 3 degrees Celsius. Alright, in order for something to be a function, there are 4 rules that need to be followed. First rule is that each element in the domain must be matched with an element in the range. Okay, so you see here, each value that's in this box, in this set A, gets mapped to somewhere in the range. And if you think about that, it makes sense because, for instance, in this example, at every time of the day, there is a certain temperature that it is. Okay, so we should always have a temperature that every value in set A gets mapped to. Okay. Rule number 2: some elements in the range may not be matched up with any element in the domain. Okay, so you see here we have 8 degrees getting mapped to something, or something gets mapped to 8 degrees, something gets mapped to 3 degrees, and so on. But if you look at 2 degrees, apparently it was never 2 degrees. At these times of the day, it was never 2 degrees. So basically that's saying that the values in the range do not have to get used in the function. Okay? And I mean, if you just think about that, we could add 120 degrees Celsius, and obviously it's never going to be 120 degrees Celsius, or at least I would hope, because that would mean that the world was probably on fire and we were all going to die. But anyways, so there can be values in the range that nothing gets mapped to. Rule number 3: multiple elements from the domain may be matched up with the same element in the range. Okay, you see here at 2 AM and at 5 AM it was 8 degrees Celsius. Okay, this is okay. It is okay for an input value, 2 different input values, to get mapped to the same output value of the range. And again, that makes sense because think about it. Is it possible that at 2 AM and at 5 AM it was the same temperature? Yeah, of course it is. I mean, that's possible. Rule number 4: each element in the domain can only go to one element in the range. Alright, this is a big rule. Basically, every value in the domain can only go to one spot over here in the range. Alright? So if you see 1 goes to 3, 2 goes to 8, 5 goes to 8, 3 goes to 4, 4 goes to 10. We don't see 4 going to 10, and 4 going to 3, and 4 going to 9. And again, that makes sense, because think about it. At 5 AM, isn't there exactly one temperature that it is? I mean, it can't be 8 degrees Celsius and 9 degrees Celsius at 5 AM. So every value in the domain can only get mapped to one value in the range. Okay, those are the 4 rules. Okay. Function notation. For most equations, you guys are used to seeing y equals something. So for this one, you'd be used to seeing y equals 1 minus x squared. Well, when something is a function, we write f of x instead of y. And all that means is whatever is in the parentheses is the value that we're going to plug something into. So for here, we're going to plug in values for x and solve. Input is x. So take a look at this example. This is read as f of 2. So f of 2 equals 1 minus 2 squared because we plugged in 2 for x. So we plugged in 2 for x. Okay? Which gives us f of 2 equals 1 minus 4, and then we find out that f of 2 equals negative 3. Now again, instead of writing x, comma, y as a point, we write x, comma, f of x, because that's our output. See, we plug in x and we solve for f of x. So let's try another one. So f of 4 is going to be 1 minus 4 squared. F of 4 equals 1 minus 16. So f of 4 is equal to negative 15, and the point will be 4 comma negative 15. We plugged in 4 and we solved to find negative 15. Alright, visually, how can we tell if something is a function? How can we tell that a graph is a function? Well, we use a simple thing called the vertical line test. And simply all that is if you draw a vertical line, that vertical line can only cross the graph one time. No matter what. You see for this first graph, no matter where I draw a vertical line, it only crosses that graph at one point. Now take a look at the circle. We'll find that this is not a function because when I draw vertical lines, it crosses at more than one point. So we see that it crosses here, and it crosses here, crosses here, and it crosses here. And that goes back to the fourth rule. If we plug in this value for x, remember, there can only be one output for every x. Well, when we plug in this value for x, we get that as an output and that as an output. Alright? So, again, this is, yes, going to be a function. It only crosses one time. No matter where you draw a line. You cannot draw a vertical line that crosses this function, this graph, more than one time. So it's a function. How about this one? Well, already you can see that these vertical lines are crossing at more than one point. So it is not a function. So we got no, no, yes, yep, yep, yippee. Alright. Okay. So go ahead and work on these problems. Little green guy says good luck. And I wish you good luck too.